So if you turned in the study guide, I returned it to you. So I know some of you I returned it and then you turned it right back in. You can't edit it or anything unless it's not turned in. So if you did return it in after this is over, I'll go ahead and return it back to you. And also, I'm putting a copy of the study guide with the answers in Science Classroom. Okay, so you'll have this video, you'll have your own study guide, and then you'll have the study guide with answers, all to help you on the test tomorrow. All right. All right, so the first question, kind of a basic question. It's got a picture of a thermometer in some water, and that the gauge is they're reading, it's got a little red line, and you're reading the temperature there. So if you count the lines up there in Celsius, our interval between the 85 and 95 is 10. So, and then there's 5 little lines. So that would mean each of these little lines right here is 2 degrees. So that would mean in Fahrenheit, this is 85, 87, 80, no, yeah, 85, 87, 89, and that's 91. So it's about, let me see what I put here. It is about 91 degrees Fahrenheit. And then in Celsius, the interval between the 30 and the 5 is 5, and there's 5 little lines. So that means each of these lines counts as 1. So we count up 1, 2, 3, and it's 33 degrees in Celsius. So the temperature in Fahrenheit is 91 degrees, and the temperature in Celsius is 33 degrees. All right, so that's question number 1. And then this is explain how to use a graduated cylinder to measure the volume of a marble. And I went ahead and I put a picture of a graduated cylinder right here. You may remember those from earlier in the year when we did the math lesson with graduated cylinders. And of course, it's got all these little lines on it. You take and you fill it up and you look at the lines and it tells you how much liquid is in there. But the question says, explain how you can use a graduated cylinder to measure the volume of a marble. Now, in the text, it tells you that if the shape is irregular, it's not a square or a cube or a rectangle or something like that, the easiest way to measure the volume is to drop it into a graduated cylinder. So the way that you do that is you put a certain amount of liquid into your graduated cylinder. An even amount would be the best. So you drop it, so you put it in about, let's say, 100 milliliters of water, right? So sitting at 100 milliliters, you make sure it's on a nice flat surface, and then you take and you simply drop the marble inside of the graduated cylinder. And then the water, of course, is going to rise a little bit. And then you take a look at the new reading. So let's say you started out with 100 milliliters of water, you dropped your marble inside, then your water raises to 113 milliliters. Well, then you would take the original measurement, 100 milliliters, subtract that from the new measurement, 113, and that would mean that the volume of the marble is 13 milliliters. All right, so a graduated cylinder is the tool we use to measure volume of an object. To measure the volume of a marble, first you must place some water in the cylinder, then you record the amount of water. You then drop the marble in the cylinder and look at the level. You subtract the first amount from the second amount, and the difference is the volume. All right, so that's measuring volume of a irregular shaped object. All right. All right, so the question number 3 says, explain how you can use a Pam Balance Scale to measure the mass of some rocks. Now remember, mass is different than weight. although we measure it the same um, here on Earth, but if something has the same mass here as it would on the moon, but something has a different weight here and on the moon. The weight is the force of gravity holding an object down, where mass is the what is inside of the object itself. All right. So this right here, this picture is a Pam Balance Scale. And the way it works, we've used these before as well. The way it works is in the center here, you have a little needle, and you need the goal is to get that needle balanced in the middle. So obviously here you have the apples, and that side, the right side, has gone down because the right side is heavier than the left side. So the object is to get the left side equal to the right side. So if you wanted to know the weight of these apples, you would simply start adding weight to the left side. And it's going to start gradually going down, down, slowly down. And then it's going to get to the point where this right here, this needle right here is right exactly in the middle. And then when it's at that point, you record how much weight you put over here, and that is the weight of the apples. All right. So let's see what I put here for the, oops, for the answer. You place the object to be measured on one side of the scale and then place weights on the other side until the center needle is balanced in the center. All right. All right, going on. Question number 4. What tool could you use to measure the mass of a wristwatch? So a wristwatch, it's not really large, not huge, but then again, it's not really small. So to measure the mass of a wristwatch, we would use either a Pam Balance Scale or a digital scale. Okay. So either one of those tools you can use to measure the mass of a wristwatch. What tool would you use to measure the volume of a seashell? Now, a seashell is an irregularly shaped object. It's not, you can't get a ruler out and measure the length and the width of it. So you must use a graduated cylinder to measure the volume of a seashell. So to measure the volume of a seashell, because it is an odd shape, I would use a graduated cylinder. All right. Moving right along. Look at the Pam Balance Scale. Again, this is a Pam Balance Scale. There's our little balancing needle right there. All right. So look at the Pam Balance Scale below. How does the mass of the white block compare to the mass of the black block? So we're looking at the black block. Now the black block is raised in the air. The white block is down a little bit, okay? So that means that the white block is heavier than the black block, all right? So, oops. All right, hold on just a second. I keep getting these emails. Let me see if I can read them. Hold on just a second. I have to send this link to Nathan. All right. All right. So as we were saying, the white block is definitely heavier than the black block. The white block is pushing the right side up into the air. So that means it is heavier. All right. The mass, let me see. Oh, come on. There we go. The mass of the white block is more than the mass of the black block. box. Okay? All right. So look around your house, find two objects that have the same shape, describe those items below. Be sure to be descriptive. Now, I'm not in your house, so I can't describe the items that are in your house, obviously. But if I was looking at your answers, this is what I would look for. Um, I would look for you describing the color, the size, the texture, and the mass. So color is obvious. You would say what color it is. You could compare the colors. You could say this is a darker color, this is a lighter color, this is red, this is white, this is black, this is blue, whatever the case may be. Now you could compare the size. This object is larger than this object. You can compare the texture. This object is rough, feels like sandpaper, while this object is smooth and it feels like glass. And then the mass. The mass is, you can say this weighs 3.6 grams, and this weighs 26 grams, whatever the case may be. Okay, so that's what I would be looking for if you were comparing comparing two objects. All right. All right, and then we have question number 8. We have 4 glasses, and each of these has a thermometer inside, and we were asked to place them in order from hottest to coldest. Now, looking at these, as we look at them, the dark part is the liquid inside the thermometer. So as the temperature gets higher, that liquid gets closer and closer to the top. So obviously the ones that are colored closer to the top are warmer, hotter. And the ones that are closer to the bottom, they are cooler. So here is the way that I arrange these cups. Cup D is the hottest. If you notice in cup D, the liquid inside, or the dark inside, goes all the way to the top. Cup A is second, so that's the second warmest, because this has got it's about 3/4 of the way to the top. And then cup B is third, because that's about halfway. And then, of course, cup C is the last. That's got the liquid is almost close to the bottom. So that is the way that you classify the temperature of the water in those. Right, ladies and gentlemen. So that is our science study guide. Again, I'm going to, well, it's already in Science Classroom. The answers are in there, and then I will also post this video to Science Classroom as well.